Yes, now we'll summarize all the inventory decisions we have mentioned so far. So these inventory decisions uh, are very key in managing the supply chain. So first thing is like when to order. This point has already been discussed previously, I think in the previous lectures. Like we have the reorder points in EOQ model, then we have review frequency. So in case of continuous monitoring, like every day I'll keep tracking my inventory. When the inventory goes below a reorder point is certain level, then we'll reorder. In case of periodic inventory, say I won't track the inventory on daily basis. I'll review my inventory after a period of time, say after every 2 days. So how frequently I'll review my order, whether I should go for every 2 days, every 3 days, or weekly basis. So there's a review frequency. Then next thing is the how much to order. So here we have a concept like order up to level. So like how much order I will place. So the input for that decision will be like one is my sales focus. Sales focus again is like a data science problem. Like you need to account for all the trends, seasonality, all your sales, everything. Then once you have the sales focus, you have the lead time, because if we place the order today, I won't get the product today itself. I might get after some time. So that lead time, I need to have a demand for the lead time, and that much of inventory I should be having while ordering. Then next thing is like how much inventory I'll be having when I place my order, how much is on hand and how much is in transit. Say some shipments already coming on their way. So while placing the order, I need to account for that in transit items also. Because if suppose already 100 items are coming, if I place another 100 items, so I will have a stockpile. So my demand suppose is 120. So 100 already is coming, so 20 I have to order.
Right.
Yeah.
And there is a possibility that even these lead times could be stochastic, right?
Yes. Yes.
So you don't know how much is the lead time. You only know the probability distribution of the lead time.
Yes.
Sometimes the lead time may be dependent on your order size. If you place the order for 100 units, the lead time will be higher. If you place the order for only 20 units, lead time may be lower, right?
Yes.
So lead
Yes.
times itself may have a lot of complications.
Complications. Similarly, say in online inventory and in transit inventory also, there will be spillage, there will be obsolete items, there will be
Yes.
damaged items in the store.
Yes. Yes.
So that also again is like a probabilistic. So you'll have how much, like if you order 100, 2 items got damaged.
Correct.
So
Correct.
the historical data will be there, how much the spillage.
Correct.
So based on that, you have to focus that also.
Yeah. Yeah. Yeah.
In fact, lead time
Yeah.
estimation is a big problem, similar to the sales forecast, because
Correct.
as you say, it's not like one data. It's not always like every 2 days, 3 days. You'll
Correct.
have a distribution.
Correct. And particularly challenging when you have global networks and your raw material is coming from a different country.
Yeah.
Really, there is no way to accurately forecast the lead time.
Yes. And on top of that, suppose your different components are coming in from different vendors, and at the
Yeah.
end of that, you have to assemble that. So unless your all the items are available, you cannot make the assembly.
Correct. 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 A synchronization problem. Right?
Synchronization problem comes to the picture.
Yeah.
And
Very,
there
very,
also, while ordering, you have to order in such a way that the items which have the maximum lead time, you should order first.
yeah.
Because otherwise, the other items will keep waiting in your inventory. And while you're
Correct.
waiting for the last item to arrive.
Correct. Correct. Very, very interesting. So yeah, I mean, even though they seem like very, very innocent bullet points on this slide, they turn out to be very challenging problems. Each of these bullet point turns out to be very challenging data science optimization problem, right? And even, yeah, I mean, so far we have not discussed the other problem of inventory rationing, right?
Yes.
So even if you place the order, there are going to be other customers who are going to place the order to the supplier. And if the supplier doesn't have enough capacity, they are going to say, well, you place the order for 90, I'm going to give you only 70.
Yes.
Because I have to satisfy my other customers, right?
Yes.
So what if there are other customers who are also placing orders like you to the supplier, and supplier is doing some kind of rationing? You don't know what that rationing rule is, but you have to manage your order size, knowing fully well that even if you order 100, you may not get 100. So yeah, I mean, very, very challenging problems, which are very realistic. I mean, this is what happens. I mean, very regularly this happens in reality. So
Yes.
these are not fictional problems, very realistic problems, and therefore complex problems, therefore difficult problems to solve. Sometimes solved using some kind of heuristics, but obviously with the power of data science, we would like to solve it optimality, right?
Yes.
That's the objective.
Yes.
Yeah, go ahead.
Yeah. So next is like where to store. So again, have already mentioned that like the soft floor, like in the warehouse, the floor forecasting, how much
Yeah.
space will be required based on how much is incoming.
Not even that, right? I mean, recently we had an engagement from an organization, and they had a, multi-tier supply chain,
Mm,
multi-echelon supply chain,
mm,
and they wanted IIT Madras to tell them where should they be stocking their inventory. Should it be at the manufacturing facility? Should it be at the warehousing? Should it be at the wholesaler? Should it be at the retailer? Where should the inventory be stored?
mm.
So even if, so they were saying that, well, even if this retailer wants the inventory, it may not be stored at the retailer's place. It may be stored at the wholesaler's place, and whenever retailer wants, she can order from the wholesaler. So the inventory required by the retailer need not always be stored at the retailer's location, because it is better to aggregate, sometimes aggregate the order quantity from multiple retailers and store it at a wholesaler, right? It may be cheaper in terms of transportation. So all these, I mean, particularly transportation may dictate where do you decide to store inventory, particularly in a global network, right? With so many places to store, some places are cheaper, some places are more accessible to store inventory, some places are difficult to reach. Some places have better opportunity to aggregate. Some places have better opportunity for lesser spoilage, right? And therefore, you want to store inventory in those places.
In fact, you need some skill set also to handle specific SKUs. So in a particular warehouse, even if it is nearer to the store,
Yeah,
that skill labor might not be available, and
correct.
there will be some storage requirements. Say cold storage should be required for certain items. Then for chemicals, another set of like hazards. Some there's some requirements are available. Again, while transporting, you need to check whether transportation how accessible in the sense in sometimes in the daytime, if it is near to the towns, the movements of materials may be restricted. So
Yes.
there, so these all things you need to account for while making decision where to store.
Yeah. And last 2 years of pandemic has
Yeah,
again thrown up very interesting challenges. Sometimes that particular warehouse is accessible because the things are all right. Sometimes the warehouse is not accessible because there is a lockdown in that area,
lockdown.
and the transportation network is broken. The flights are not taking off. So what happens in those cases where there is a disruption in the network, right?
Yes,
How do you plan for these disruptions? How do you
yes.
still optimize? How do you still optimize, knowing fully well that some of your locations may not be accessible for various reasons?
And in that lockdown period, there also one problem came like centralized storage. Instead of centrally locating all the items in the one place, you
Yeah.
just decentralize things so that if the facility has been locked down, your
Yes.
entire supply chain is not disrupted, specifically in the vegetables. So all
Yes.
the vegetable mandis, if there's a lockdown, there's shortage in the cities. So how we will take care of that? Yeah.
Correct. So,
Uh,
yeah,
and in
very
fact, there
interesting.
is one more thing like just in case supply chain, if something happens, some natural calamities happen, there's a flood somewhere, then
Yes.
how will source those items? Where will you store again?
Yes. And this may, I mean, these kind of natural calamities may probably increase your lead times, right?
Yes.
So auto manufacturer sources the engine from some location,
Hmm.
and let us say that that particular place has floods. So your entire car assembly is available except for the engine. So what good is that assembly? So and therefore the delivery of the car gets delayed till the engine arrives. So lead times get affected, and I'm talking purely from my personal case. I would have bought a different car if some part was not flooded and the engine delivery was not delayed. So I have so the dealer told me that, well, if you want to buy that car, you have to wait for 7 more months. And I said, well, I'm not willing to wait for 7 months. So the lead time quoted was 7 months. So, and I was not willing to wait for 7 months. So I opted for a car which was available immediately. Definitely impacts that. So just in case supply chain are important in those cases. Essentially,
Yes.
what we are talking about is a robust design, right? Essentially, our supply chain network has to be robust, which accommodates all these possibilities.
Yes. So
And
here one thing,
essentially,
like as you mentioned, like there's a back order scenario. So already items have been booked and you have promised that I'll deliver these items to the customers, and something happened. Like once you figure out how to come up of that calamity, you have sourced from alternate way. Now you have a huge volume of orders we need to deliver. So in the
correct.
last mile case also, there's a huge pressure on that case. Say when the items arrive, now in short period you have to meet all the customer demands which are already waiting.
Correct.
Yeah.
Correct. Very, yeah. And yeah, I mean, this has to be reminded to our participants, because in all my discussions earlier, we had said, let us not consider back ordering, let us consider lost sales. But if we do consider back ordering, things do get complicated. Yes.
Complicated. Yeah. Yeah. So once we make the like storing decision, then we have to identify where the SKU is. Suppose in the warehouse, large warehouses, lakhs of items have been stored. Now when the demand comes from the stores or any other local warehouses, now you have to locate that SKU that already we have discussed previously. So for that also you need a mechanism that you have to track those SKUs for their levels, like how much quantity is there. So there again, RFIDs will be there, tracking systems. And
Correct.
next thing is like allocation of items to stores from different warehouses. Now you have one regional distribution centers. From there, there'll be district level warehouses. Then from there, different thousands of stores. Like which store will be allocated to which warehouse. And suppose in case your demand, you have the store has given a demand and a warehouse is not doesn't have the sufficient quantity to meet the demand. What will be the next warehouse which will be allocated? And again, suppose you have a part of the inventory is available in a warehouse. Now, whether you will source the entire demand of that store from another warehouse or a portion of that from the nearest warehouse and the next the remaining items from another warehouse, because it will have a implication on transportation cost.
Yes. Yes.
And here we'll see one use case for that small use case, how the allocation affects your service level. Service level means how much percentage of the demand you are able to meet.
Okay. You have data for that.
Yes.
Oh, okay. Okay. Yeah. Yeah.
Yeah.
So, sure.
And last thing is like the shelf space allocation. Like in the store levels, how much item I will put for display and where. This is a very interesting problem that we have already discussed. So here, three important things. One is the impulse buying. So generally, if you go to while you're paying billing during
At the
billing,
checkout
yeah,
counter, right?
checkout time, we'll have a lot of items kept nearby. So if you don't have change or suddenly if you want to purchase a chocolate, you'll pick it up.
Yeah.
Like this is unplanned. Suddenly your demand is arising in those POS
Very,
system.
very, very, very true in case of retail,
Yes.
right? Retail industry does that very often.
Yeah. And you have a lot of chips packets nearby the counters,
Yeah,
biscuits, you have chocolates. And if the inventory is more like a lot of items are stored
yeah,
there, people
yeah.
also will tend to get a piece of those
Correct,
items.
correct. And essentially, the items that are stored near the checkout counters are never the utilitarian products. They are all hedonic products, because
Yes.
utilitarian products you would have already purchased,
Yeah,
right? If you know that you need a shaving cream, you would have bought the shaving cream. Uh, the impulse buying is essentially for all the hedonic items which you don't actually require, but you buy it only because it's right available right there, right?
yes,
So it essentially the location of the inventory creates the demand for the product.
exactly.
Since it is located right there in the checkout counter, you would not have otherwise bought the product if it was actually stored on the aisle.
Yes,
You buy the product purely because of the location at which it is stored in the store.
yes,
Awesome. So yeah,
yes.
I mean, and once again, I mean, we should ask our participants: isn't that what happens? If every time you go to a retail store, this is what we do. And I mean, I regularly impulse buy. I do that.
Yeah,
So
same here. Then
But
next is invent. Yes,
yeah,
sir.
this is also a very interesting marketing problem.
Yes.
A lot of marketing researchers study impulse buying.
Yeah.
Yeah, so not only interested in the sense of optimization, in the sense of inventory, also in I mean everything that we do, right? I mean essentially we're talking about sales,
Hmm.
and sales should also be interesting to marketing folks.
In fact, here the experimentation also happens. Like different, you put different items, you have scope for experimenting, like which items go fast, which
Yeah,
items are actually a candidate for impulse buying. Not
yeah,
every items will actually will enjoy this benefit of
yes,
impulse buying.
yes, yes, yes.
And next thing is like inventory dependent demand. So this is another interesting topic. So in some cases, if you have more inventories, people will find it more accessible and they will buy more. But in other cases, high-end product, if the item is easily available, then it will lose the prestige. So people might not go purchase that. Say if tomorrow some very costly car, say Benz or some, is easily available everywhere,
Yeah,
then will you buy it?
yeah,
I don't think,
correct.
because then it will become like a very generic product.
Yes,
Yeah.
yes. So I mean, once again, happens quite often, right?
Hmm.
If there is too much of inventory in a retail clothing store,
Hmm.
there are just piles and piles of shirts kept there, and quite likely the shirt at the bottom is going to accumulate some dirt,
Yes.
because I mean it happens. Not because the inventory is old, it's
Hmm.
just because there's just too much of inventory lying there,
Yeah.
and the customer will think, see, there is a dirt accumulation, and people are not even buying this shirt,
Hmm.
which will essentially dampen the demand for that particular product. So, but yeah, I mean, both cases may happen. Both
Hmm.
cases may happen. For some products, easy availability of the product, which means a lot of inventory, promotes demand. In certain cases, a lot of inventory visible to the customer actually dampens the demand. Both may happen.
Yes. And
Uh,
if
and,
one
and
more thing happens, sir, suppose if there's a lot of substitution and you don't have much demarcation between those options. So if item one is not available, you'll purchase an alternative item. For example, you have three types of chips. If the chips type one is not available, you won't mind buying the chips type two.
yeah,
So
yeah,
in that case, like your inventory, if more the inventory, you have more sales.
correct. So, but there you're talking about inventory of different SKU, which is similar to this SKU, right?
Yes,
The similarity index and all that will matter.
will matter.
The product distance, right? The what is called as hoteling distance, that
Yeah.
will start to matter, and we have seen mathematical models of that kind.
Yes.
So, what do you mean by complementary and substitutional products?
Complementary is like, suppose you are purchasing tea.
Okay,
Make to have a cup of tea, you need sugar also. You need milk also. So when you purchase tea, you will tend to purchase sugar also, milk also. It's a complementary product. Yeah.
retail stores are better served if tea and sugar are stored
Nearby.
nearby. Okay,
Yeah.
okay,
So
yeah,
that
yeah,
suppose if I while I purchasing tea, if I might not, I might forget to buy sugar. So if
yes,
that item is nearby to that, then the customer will remove. It will remind the customer, okay, you have to purchase this item also.
correct,
We'll
correct,
see on
and
online purchasing also, they will recommend the system. Customers
yes,
also buy.
correct,
So they
correct,
will identify your searching behavior and your purchasing behavior. Then
yes.
they'll recommend your product.
Correct. And I mean, this is not a new idea, because our participants will remember that we had discussed something called a priori algorithm some weeks ago,
Yeah.
which is what we were trying to do. We were trying to find out which suppliers are close to each other. There, the problem for a priori algorithm was supplier selection. Here, it is the SKUs. So essentially, we are talking about how similar or how complementary the SKUs are. So how SKUs are bought together. So think of data where every row is a basket of items purchased by each customer. So that goes in the rows, and different columns represent different SKUs. And if you run a priori algorithm, the result will tell you which items were bought together. So essentially, conditional probability of buying a particular product if some other product has already been purchased. So that's what Gemini means by complementary product, right?
Yes. Yes, sir.
So yes, so we have seen a different application of a priori algorithm, but a priori algorithm can also be used to identify which are complementary SKUs, right?
Exactly.
And that is true for many mathematical models that we have seen in this course. They were explained for that particular application doesn't mean that they are only applicable to that scenario. The algorithms are quite generic. We can apply it to many applications, and we just have to find out which suits best. In
Exactly.
reality, no problem comes to us saying that you know what, this is an a priori algorithm problem. No problem. No situation comes to us like that. Only in the academic courses, the question paper will say solve this problem using a priori algorithm. In real life, it doesn't happen. We are supposed, as a data scientist, we are supposed to find the appropriate algorithm and apply that to the scenario, hoping and hopefully we have done our analysis correctly, that our algorithm is the best suited algorithm for that.
In fact, while solving a problem by data scientists, they will actually apply multiple algorithms, then find where the solution is best.
Yeah,
like
but I'm not a big fan of that kind of approach,
exactly.
right? I mean,
Yeah.
so I mean, there has to be some prior studying done saying that, well, you know what, out of these 10 algorithms that are available to me, 3 are not even applicable to this
Relevant.
scenario.
Yes.
So I don't think that data scientist is a good data scientist saying that any problem that comes, I will apply these 10 algorithms irrespective of what problem comes to me, right? So
Exactly.
there has to be some filtering done, some shortlisting done, saying that out of these 10, I will try these 3 and then pick the best, which algorithm suits the best, right? So
Yes,
something
there
has
we
to
have
be
to
done.
take about the assumptions, like what assumptions fit. We'll consider those that are candidates.
Exactly. Yeah.
Definitely. Yeah. So other thing, the opposite of complementary is like the substitution product.
Right.
So in substitution, say if you are purchasing tea, if you're tea lover, you might not be a coffee lover. So either you purchase tea or coffee, not both, general cases.
Yeah.
So in such cases, one of the product demand goes up, the substitution product, its demand goes down. So again, this is to identify, similarly, that for data scientists, they have to identify from the data, like what might be the substitution product. So there also experimentation also happens, because not necessarily if there is a trend in such cases, not always is a substitution product. It may be, it might not be.